Hi everybody. So in exercise 6 we will solve 10 parts in several videos. The first question is to determine the domain of definition of the function f. Part 2 is to show that the straight line of equation x equal to 0 is an asymptote. Part 3 to determine the limit of the function f at plus and minus infinity. 4 to show that the straight line y equal minus x is an asymptote. Part 5 is a new part. It's to study the relative position between curve C and with respect to the asymptote D. Part 6 to set up the table of variation. 7 to write the equation of the tangent of abscissa at a point of abscissa minus 1. And part 8, which is similar to part 5, the new part is to study the relative position between curve C and the tangent T. Also part 9 is a new part to find the intersection points between curve C and x prime y x. Then to draw the curve C and the straight line or the asymptote D. So in this video we will solve part 1, 2 and 3, and 4 will be a homework. So first of all we need to determine the domain of definition of the function f, which is x squared minus 1 over x squared over x. So f is defined when x is different from 0, that is x between minus infinity and 0, or 0 plus infinity. Part 2 is to show that the straight line of equation x equals to 0 is an asymptote. Any straight line of equation x equals to a constant, to be an asymptote, then this straight line should be a vertical asymptote, because the vertical asymptote has an equation x equals to a constant. Here the constant is to 0. Constant means that any number independent of x. So in other words, we need to prove that we need to find the vertical asymptote to the curve C. And in order to find the relative asymptote to curve C, we always find the limits on 0 plus and 0 minus. This depends on the domain of definition. So in our case here we have the domain of definition between minus infinity 0, 0 plus infinity. So the only to find the vertical asymptote, then it is sufficient to find the limits on 0 plus and 0 minus, and then we can deduce that x equal to 0 is a vertical asymptote. So first of all, the limit at 0 minus, we replace x by 0 minus in the expression of f. Then we will have minus 1 over 0 minus, so minus over minus is plus, number over 0 is infinity, so the answer is plus infinity. Similarly, the limit at 0 plus is minus 1 over 0 plus, which is minus infinity, and then we can deduce that the line of equation x equals to 0 is a vertical asymptote. Question 3 is to determine the limit of the function f at minus and plus infinity. So first of all, to find the limit at plus infinity of fx, that is to find the limit of the highest power in the numerator expression and the highest power in the denominator expression. So this is equivalent to find the limit at plus infinity to f of x. So limit plus infinity of x squared over x. Before replacing x by plus infinity, do a simplification, so x squared over x is x. Then to find the limit at plus infinity of f of x, it is equivalent to find the limit at plus infinity of x. So now replace x by plus infinity, the answer is plus infinity. Similarly, to find the limit at minus infinity of f of x, then it is equivalent to find the limit at minus infinity of the expression x. Replace x by minus infinity and the answer will be minus infinity. So please do only part 4 as a homework.